And today I will be talking about the Lab 7 Relational Logic in my Comp 380 course, Introduction to Artificial Intelligence. So, what are the preliminary? We have a few preliminary questions. That's what is top-down proof procedure? A top-down proof procedure, also known as goal-directed reasoning or backward chaining, is a method used in artificial intelligence and automated theorem proving. The basic idea behind this approach is that we start with a goal or a desired outcome and then work backwards to find a sequence of steps that lead to that goal. And I have described more about it in my solution. The next question is, if you how do you know when you have completed a successful derivation of it using top down? So to know that, we need a few main points. That's if the goal is satisfied, and we have no more steps to go through, and or during the proof that all our steps are consistent and they are valid, and then there's no termination conditions, and then the proof trace is there. Next we have is what to give an example of an admissible heuristic for a top down search. So in this case, I've taken a scenario where we need to schedule three tasks, and that the total duration of our schedule should be minimum possible. So initially, all my tasks are unscheduled, and I'm at the beginning of the planning process. After uh, an admissible heuristic at this point would be the estimate to would be to estimate the running duration by considering the maximum duration of any of the unscheduled tasks. So, for example, B has the longest duration. So, once we start scheduling the task, suppose we have scheduled task A and we are left with B and C. So, the admissible heuristic at this point would be task B because it has the longest minutes, 25 minutes. Now, the next question, we were given a knowledge base, and we were supposed to find know if Chris has been accepted into a university. Uh, we needed to check that. So our goal at this point would be to check if Chris has been accepted. We have two rules to check that to know if he has been accepted. First is if he's a returning student and in good academic standing, and his previous balance or any of remaining fees has been cleared. So Chris is not a returning student, so he is not applicable. He's not applicable to this rule. Next, we will try the second rule that says if he would be accepted if his application is complete and he's a qualified student. So we know for a fact that his application is complete. So we will focus on the fact if he is qualified. To check his qualification, we first check if he's a legacy student. There's one rule under legacy student. So he is a legacy student. We'll check if he's a legacy student. So to check that, we need to be sure that he is a child of someone who has graduated from the same university. So we know for a fact that there's a guy named Sam who has graduated from this university, and that Chris is uh, the son of this same person, Sam. So substituting this rule into these two facts into this rule, we get to know that yes, Chris is a legacy student. So once we uh, substitute back into the qualified, if he because he's a legacy student, he's also qualified, and he's qualified as well as his application is complete. That means that he it has been accepted. So our derivation is complete, and we know that Chris has been accepted into the university. And when I tried this problem on AI Space, I got the same answer. As you can see, that the result is true. The next question was to do the same for Laura. Now Laura is a returning student, so for returning student, she needed to be returning in good academic standing and have a clear balance. We know for a fact that she has is a returning student and in good academic standing, but her balance is not clear, so she is not accepted due to this rule. Also, her application is not complete, and she's not a qualified student because she's not a legacy student. So this she's also not accepted due to this rule. So overall, she has not been accepted into the university. Thank you.